Hey students, this is lesson 131. In this lesson, we're going to learn that how to tell if there's a linear relationship between two variables by looking for a constant change. And to get started here, just think about this question. Suppose you want to determine if a relationship is linear. Would you rather use a description, an equation, graph, or a table to make your determination, and why? If you want to pause here and think about that. I personally think I like looking at a graph the best, because if you have a graph, you can instantly tell if it's linear if the points line up. So that's a straight line, so that would be linear. This is a curved line, so that would not be linear. Anyway, so that's my idea there. Now, Sierra wanted to determine whether a set of values could be linear, and she actually has 4 sets of values. So we're going to look at these sets of values and decide whether or not they're linear. And we're going to use the method of constant differences. I'm going to do a couple from here, and then I'm going to do a couple from develop and understand A that I think we might want to look at. But anyway, if let's just do table 1 here. First, I'm going to look at the inputs. And inputs, we can think of those as the x values, and output the y values. So here we have a table, and our input values are going up by 1, so plus 1 every time. That's kind of convenient. So all we have to do to see if this is linear is make sure that our outputs are going up by that. And to do that, you just subtract any consecutive output values. So 7 minus 4 is 3. 10 minus 7 is 3. So this is going up by 3. So since both variables are increasing by a constant, we know that there's a linear relationship. So we know that table 1 there is a linear relationship, and one way we could just make sure is we could draw a graph of that relationship. So if we put a point at 1, 4, a point at 2, 7, a point at 3, 10, we see that there is definitely a linear relationship. And we don't even need to plot any more points to see that. This relationship would also continue this way. So, and we can see here also that the slope is 3. That means that for every 1 I go over, I go up 3. And that we could also come up with an equation for that. And if you remember back, the number you multiply by x, that's the constant difference, or the difference in y values here as the x values increase by 1, which is 3. So our equation would be 3x plus, and then the thing you add on is the output value when the input is 0. So if in this one, I might need to go back 1 step, and that's one way to find that. So if I go back to 0 here, I would need to subtract 3 from 4, and that would be 1. So 3x plus 1 is the equation. All right, let's do one more of these, and then we'll look at some other. Let's go to the last one here and just check that one out. So table 4, just by looking at the values in that, these again, they go up by 1 in inputs. And as those go up by 1, the output goes up by 5. 15 minus 10 is 5. 21 minus 15 is 6. And 28 minus 21 is 7. Those aren't going up by a constant. The amount they go up by is changing. And I'm gonna go ahead and graph that: 210, 315, 421, and 528. And to do that, I'm going to have to change my scale on my graph. My largest value is 28, so I'm going to use a scale of 3 on the y-axis. So this will actually be 6, and 12, and 18, 24, and 30. And I'm going to graph the points 210, 315, 421. So over 2 up 10, that's going to be about right there. Over 3 up 15, that's right there. Over 4 up 21, that's about right there. And over 5 up 28, that's right there. And if you look closely, you can see that it is starting to curve. And I'm just going to throw a couple more points in here. If I go back a little bit further to 1, I would be, to get to the 10, I would have added 4. So if I'm working backwards, I do 10 minus 4, which is 6. And then 10 minus, then 6 minus 3 is 3. So 0, 3, 1, 6 would also be in that table. So 0, 3, and 1, 6. So if you look closely, you should notice that the line is starting to curve up. It's not a linear situation. The table really helps us tell whether or not it's a constant. Okay. The other thing we wanted to do here is draw a graph, extend your graph, and estimate the output for each input of -3. Which estimates do you think are most accurate? So on this one, on the first table I did, we saw that it was going up at a constant rate of 3. So as I work backwards, I can just move over 1 and move down 3. So at -3 here for my input, my output is right here at -8, -3, -8. That wasn't too hard. But on this table 4 that I did, if I work my way back to -3, I have to keep changing how much I subtract. So in a table, it's a little easier. If I go back to -1, I would be subtracting 2 from 3, which would give me 1. The next one back, I would be subtracting 1 from 1, which is 0. And then I would be subtracting -1, which is actually adding 1. So at -3, I would be at 1. -1, 1, -2, 0, -3, 1. So this is actually going to come down here and then start to curve up again. That was kind of hard to find. So which estimates do you think are most accurate? And I'm going to say the ones for the linear situations. All right, let's turn the page. I'm going to do one more on this page with you. Sometimes the tables are all messed up and it's a little bit harder to tell if there's a linear rule, like number 2 here. So one thing I'm going to suggest you do on that, in that case, is maybe reorder them. And we have 0, -2. Then we have 1, 7, 2, 16, 3, 25, 4, 34, 5, 43. And if you look at them like this, now these are all in order, they're +1. And the y values are +9, +9, +9, +9, and so on. So is there a linear relationship in that one? Yeah, every time x goes up by 1, y goes up by 9, so there is a linear relationship. And you didn't have to erase that in your paper, but so yes, there is a linear rule. And the rule is, since I'm going up by 9, y equals 9x plus, now I need the output value when the input is 0. And that's my number I want to add here, -2. And just checking that, if you like took 9 times 3, that's 27 plus -2 gives you -25. That checks out. So that's the end of the lesson today, and the rest of this we'll do in class. But basically, you're trying to find a pattern of a constant change to help you create a rule, and that's called the method of constant differences. So why don't you, for tomorrow, why don't you go back to this and go ahead and finish up these table 2 and table 3. And be ready to share that. So we're using these two. Come up with, go ahead and graph them, see if you think they're linear. If they're linear, write the equation for them also. All right, see you tomorrow.